Hi, and welcome to this lecture about the heat market. In this video, I will present the example of the heat market in Copenhagen, Denmark. The objectives will be to understand what were the main drivers for opening up the heat market, what are its main characteristics, and its most recent evolutions. But first, let me give you a bit of background history. The rapid expansion of district heating is a direct result of the 70s oil crisis, where Danish authorities implemented huge national heating plans to overcome their dependencies on oil imports for heat and electricity production. This resulted in the construction of centrally planned district heating that you can see in green on the map, powered by nearly 300 combined heat and power plants, or CHPs, that today supply the 2/3 of the district heating demand. This boom in CHPs was actually the main driver for opening up the heat market at the time of the electricity market opening in the 2000s. Indeed, because CHPs are facilities able to produce both electricity and heat at the same time, and because they are owned and operated by municipalities and therefore regulated, their participation in newly deregulated electricity markets was going against the newly signed directives and created a risk of distorting competition on the electricity market. Let's now step back 1 minute and define what district heating is. District heating is a collective heat supply used for space heating and hot domestic water. The hot water flows from the heating plants down to the buildings in insulated underground pipes. District heating networks are built on transmission and distribution pipes. The difference between the two levels refers simply to the physical specificity of the network, where heat, temperature, and pressure decrease the farther we are from the heating plants. The Greater Copenhagen area now counts 2 interconnected transmission networks in blue, on orange, and yellow on the map that transport heat from the largest plants down to 17 municipalities. So it is a very large system. On the supply side, we count 4 large CHP plants that are owned and operated by 2 competing independent heat producers. There are also 3 waste incineration plants owned by the municipalities, 2 large heat accumulators, and about 40 decentralized plants used as reserve during winter that are also both owned by the municipalities. In 2008, a heat dispatcher called Varmlast was introduced. Its role is to optimally plan and dispatch heat, to ensure the full transparency on the energy flows, and to communicate the cost of operation that are declared by the market participants to the regulator. The heat market design Copenhagen follows 3 steps. First, the day ahead, the intraday, and then the settlement. On the day ahead, which is actually 2 days ahead, the network operators send their load forecasts to Varmlast, to the dispatcher. The CHPs then declare the state of their generation capacity and their operating costs for each hour of the next 48 hours. And this very much depends on their simultaneous participation in the electricity market, especially. CHPs must deduct from the operating costs they declare to Varmlast the hourly revenue they make from the sale of electricity. Based on that, Varmlast prepares a heat production plan for each hour that gives the optimal technical economic hourly combination of heat production on the overall system. At this point, it is very important to stress that the heat market is not intended at clearing prices and at paying producers. This will be done at the settlements, as we will see later. Now, on this graph, you see the contribution of the heat technologies during a winter week. Within green, the waste incineration plants, in blue, the CHPs, and in purple and orange, the peakers. The intraday market corrects imbalances. The 48 day-ahead plants are revised 6 times a day during the day of delivery to take into account any deviation in heating demand, electricity prices, and any potential issues at the heat plants. Here, all relevant plants, whether they are large or small CHPs or decentralized, can participate and are selected following increasing cost criteria. Finally, the settlement aims at matching heat supply and payment. The payment for heat supply is defined ex ante in bilateral contracts signed between heat producers and network operators, and these are confidential. The contract sets a volume of heat to be delivered in a given month, and the price per unit of heat that remains constant until it is renegotiated by one of the parties. The settlement is made on a monthly basis, and in the end, lower or higher revenues resulting from the effective delivery as compared to what was indicated in the contract are counterbalanced at the next period. Now a little bit of concluding remarks and food for thoughts. In 40 years, district heating in Denmark has evolved tremendously to include more performant technologies. Today, district heating has become a critical instrument to meet the climate objectives, notably in replacing fossil fuel-based CHPs with biomass and investing in thermal storage and power to heat that store and use electricity surpluses coming from wind generation. Today, Denmark is developing new heat technologies, energy sources, and storage to meet its full heat decarbonization targets. In parallel, more cross-sectoral integration is in the making between heat and electricity, and primarily through the centralized heat pump part with renewables again. A new regulatory framework is also being implemented to recover heat losses from large businesses such as data centers or big supermarkets. The special place of cogenerators at the interface between heat and electricity was the main driver 20 years back to introduce market mechanisms in the heat market. Now, how the multiplication of those new players having the possibility to sell or store heat will affect competition and current market rules remains to be invented. Now, thank you so much for your attention, and I hope that you learned something new and exciting about district heating.